Hello students, welcome to TSS Tutorial Center, where we make complicated topics very simple to understand. So if you are under natural and applied sciences and you want to become good, you want to become better, you want to start thinking outside the box, then do subscribe to this channel, because we break down complicated topics to something which you're going to understand in just a short period of time. Fima Zwibo dude. In this tutorial, we'll talk about complex numbers, and I assure you, even though the word sounds to be very complex, it's actually very simple to understand. If I was told to give a nickname to this topic, it could be actually simplest numbers, because it's very simple. So let me show you how simple it is, and make sure you watch till the end, where I'll talk about the polar form, how you are going to find the argument in the modulus, because how we're going to be finding those guys is going to be very interesting. Okay, so the question is, what is a complex number? A complex number is just a number which is in the form z is equal to x plus I y. In this form, this is a complex number which is in the form x plus imaginary unit. The I is known as the imaginary unit times y. Now, where x and y, they are real numbers. They are real numbers. That is a number that you can think of in the world. From negative infinity to positive infinity, a number. Whether it is a decimal point, a number. They are real numbers. Now here, the imaginary unit, the I, is called the imaginary unit and is represented by the root of -1. The name is the imaginary unit, but it is represented as the root of -1. However, when you're talking about the complex numbers, the x and the y, they are the parts of the complex numbers, and they have been given the name. The x is known as the real part. Why? Because it will never have the imaginary unit. It is known as the real part. But when you're talking about the y is known as the imaginary part of the complex number. This is what we are saying. The x is known as the real part, and the y is known as the imaginary part of the complex number. Now, these two, the real part, it is denoted as the reals. I usually call it the reals. Then the imaginary part is denoted as the ims. I usually call it the ims. I don't know how you're going to be pronouncing it, but that's the way I do it, so that I don't forget what I'm talking about. We are saying the real is denoted as what? The reals. And the y is known as the ims. That's what we are talking about. Now let's talk about the imaginary unit and the things that you're supposed to know about the imaginary unit. They're actually very interesting. Let's dive into it. Okay, the imaginary unit, you're saying it is represented as it is equal to the root of -1. Now, there are actually two vital things you're supposed to know about the imaginary unit. Actually, how many two things you're supposed to know about the imaginary unit? These are, you're supposed to know when it's raised to the power 2. Yeah, it sounds very simple, but in a lot of questions it's going to be applicable. And you're supposed to know what it is when it's raised to the power 4. Let's talk about this in detail. We are saying the imaginary unit is equal to the root of what? -1. So we can say that -1 is equal to the I. Okay, so when it's raised to the power 2, what does this mean? I get my -1 inside the root, then I raise it to the power 2. Definitely you can see that the root and the square, they're going to cancel, so the answer you're going to get is -1. So always do remember, when you multiply I times I times I, the imaginary unit times itself, you should get -1. This is very much important, because in a lot of questions you're going to be doing, it's going to be applicable. Keep in mind. Now, it is equal to -1. Now, what if it's raised to the power 4? This is also important because it allows you to simplify what you've been given. What if it's raised to the power 4? We're saying when it's raised to the power 2, it's equal to -1. So we can divide this as I raised to the power 2 times I raised to the power 2. And we know that when it's raised to the power 2, that is 1. Raised to the power 2 again, 1. So definitely we'll get what? 1. Because when it's raised to the power 2, we're getting -1. Again raised to the power 2, get -1. -1 times -1 will get +2. This is very, very much important. So for the last one, raised to the power 2, let's have some examples and I show you how to go about it. Okay, so these are the first examples we are going to do. Okay, so the first one, look at the question. Simplify the following. I raised to the power 36. Now, it's very much important to know this. Since you know that when I is raised to the power +4, it is equal to 1. That's what we're going to be using here. When it's raised to the power 4, it is equal to what? 1. So, I'll make sure the 36 in number, the power that is going to be raised to, I divide it or I break it down in terms of 4. Now, how do I do that? Okay, so let's break down 36 in terms of 4. There you are. Want to break you down. To divide by 4. When you divide by 4, you ask yourself, how many times can 4 go into 36? That is 9. So you multiply again by 9. Do you have any remainder? No. So you say plus 0. Or you just say there is no. When you multiply this on your calculator, definitely you're going to get 36. So nothing has changed. The power is still 36, but in terms of what? 4. Now, I know that this expression is same as I raised to the power 4, then open brackets 9. I know that when I is raised to the power 4, it is actually equal to what? 1. So it will be 1 raised to the power what? 9. And this is going to give us what? 1. Very much simple to simplify. Let's go to the next one. You should do the last one. It looks complicated, but it's actually simple. 86. I'm sure you're going to see it. Let me talk about 49. Okay, so we can see 49 there. We want to break down 49 in terms of what? 4. So, how are we going to do so? You say 4. Then, how many times can 4 go into 49? 12. So you multiply by 12. Is there a remainder? Yes, there is. That is 1. Now here, not a lot of people, you get confused here. When you're talking about indices, okay, suppose you have a raised to the power n times a raised to the power m. What do you do when you're multiplying indices? Two numbers of the same basis, you maintain one base, then you add the powers. So it will be n or m plus n. Multiplication is commutative. Now, what are we saying here? I can also take this guy to give me this one. This is what I'll do. This expression is the same as the expression which is here. I have powers adding themselves, which means is I raised to the power 4 times 12 multiplied by I raised to the power 1. If there was a remainder of 2, this I could have been raised to the power of what? 2. So definitely now we know that this guy is 1. So it's 1 raised to the power 4 times I. This will give us what? I, the imaginary unit. We're done. That's all you need to do. Zibo, Zibo dude. Let's move on to the next thing. You're seeing this one we've talked about is very simple. Let's talk about the conjugate of the complex numbers. Complex numbers. Okay, so when you're talking about the conjugate of a complex number, it's actually going to be simple because you have talked about sides. See, in the, I think sides, they are much complicated compared to the complex numbers. As long as you know that the imaginary unit times the imaginary unit is going to give you -1. Now, we're supposed to talk about the addition, subtraction, multiplication, also division of complex numbers. But what we're going to do is we'll talk about the conjugate. The conjugate is going to have the addition, the subtraction, it's going to contain everything. Now, let's dive into it. Let's do an example. This one. Very simple. This example is very simple. Now, these things you're supposed to be smiling, like I always say. Some things you should just be happy. You hear the word there. I'm going to know this and I'm going to break this down. Look at this guy. They're asking us divide this complex number divided by this one. That is, let's start with the first one. Okay, so we have 3 minus 6i divided by 2 times the imaginary unit. Okay, so what are we supposed to do here? You don't divide the complex number here. These two are direct into what you have on top. No. What do you do? So when you have the imaginary part, just the imaginary part as your denominator, you just multiply by I. You multiply by I. You multiply by the imaginary unit, not the conjugate. Not the conjugate who is supposed to change the negatives. Just multiply by I. If it's going to be called the conjugate, let it be called the conjugate. But we'll talk about the conjugate and how it's supposed to be. But in this case, you don't want to confuse yourself, do a lot of unnecessary things. Just multiply by I. I repeat, when you have the imaginary part being divided into the complex number, what do? You multiply by I, both the numerator and the denominator. Let's do so. So you have I times the imaginary unit times 3. It will be 3 imaginary unit. Again, you have, okay, so here, this is going to be positive 6 because we know that I times I is what? -1. So someone in inside him what? -6. So a lot of people makes mistakes on that one. Be careful. This is going to give us -2. I repeat, I times I is equal to what? -1. Now we want this to be in form of a complex number. So what do? You start dividing. What is 6 divided by -2? That is -3. What is 3? I divided by -2. This will just give us this. Then we're done. We're done. Yes, we are done. Let's move on to the next one. It might look complicated, but it's actually the same. Okay, so the second one, you're seeing we're not dividing just by the imaginary part. The complex number also have the rows. Okay, so let me show you how to get the conjugate. We should definitely know. Okay, so the conjugate, what's going to be the conjugate? Just going to be the negative. Since we have the positive there, so here it will be negative 4i. What happens to the denominator also happens to the numerator. So even the numerator, we're going to multiply by the same one. There we go. Okay, so multiplying 1 times everything that we have inside this bracket. Okay, that's going to give us, just come back the same way there because we are multiplying by 1. Now, let's try I times 3, that's going to give us positive 3 imaginary units. What about this one? Think about it. What are we going to get? Imaginary units times negative 4i. Definitely we're going to get positive what? 4. Okay, so you should be used by now. Whenever you hear someone saying I times I should be coming in your mind. Boom, negative 1. What about this one? So when you're multiplying the conjugate, don't start multiplying everything. You're going to be wasting time. Just multiply 3 times, you multiply the corresponding terms. 3 times 3, that is 9. Again, 4 times negative 4, that is negative 16. I times I, that is negative 1. So this side we're going to have positive 16. Okay, thou shalt continue. You know how to collect the like things. Let's talk about the addition. Fire, in the name of Jesus, you don't add the real part plus the imaginary part. That's very demonic. You don't do so. You can't add 2x plus y. What? You don't. You don't, my dear. So this one, 3 minus 4, nothing is going to happen. Nothing is going to do what? Happen, my dear. What we'll do is 4 plus 3, which is going to give us 7. This one and this one, they are the like terms, so you can subtract, and it's going to give you negative what? I. Then our denominator is going to be 25, which I can divide individually, 25. Then this side, 25. Okay, we are done. Very simple. As if we're drinking kangoyo. The bab kuroba bantu bamonaka ba promoter. Moving on to the next one. Zuibo. Zuibo dude. What about this one? Okay, so you can pause the video and you should try it. Actually, very simple as well. Let's do it. Okay. This is the first one. No. Okay. So we have 5. Okay, so let's multiply. What is 5 times 7? 8. 5. 5 times I, that is 5. I. Again, negative 3. I times 7, that is going to be negative 21. I. Negative 3. I times I is going to give us positive 3 over, don't do anything to the denominator yet. Finish what you have on top. 2i. So right now I'm enjoying 2i, 2 minus I. Now look at this one and this one. They'll definitely do it. So we have 35 plus 3, which is going to give us 8. Now, okay, from there we have 5i minus 5 minus 2i, which is going to give us what? Yes, you're right. Going to give us this guy. Wait just a minute. We multiplied here times 3. So we have 5 minus 21. That's equal to what? That's equal to 16. So it will be negative 16i then over 2i. Okay, now here we can find the conjugate. The conjugate, very simple, just going to be 2 plus I. Even here, 2 plus I. Okay, so we have 38 times 2. What are we going to get? 76. 38 multiplied by the imaginary unit, that will be 38 imaginary unit. Okay, 16, negative 16i times 2, that is going to give us what? Negative 32i. Then, the last part, we are going to get positive 16. That is negative 16i times I. Then what did we see when we were multiplying the conjugates? We go direct. 2 times 2, that is 4. I times I, giving us positive what? 1. Okay, 76 plus 16, that is 92. Then we have 38i minus 32i, which is 6, going to be positive, divided by 5. So definitely this is going to be equal to 92 over 5 plus 6 over 5i. We're done. Okay, so the key I think is just to know the conjugate and how to multiply the conjugates so that we don't waste a lot of time. And also, I times I is equal to what? Let's move on. Okay, so let's talk about the complex plane, the way it's supposed to be. I'm going to talk much about it. It's also known as the angled diagram. So the way it is, you have the I as the ims as the y-axis and the rows as your x-axis. Then the complex number will be drawn as the one which is passing here. Okay, so this guy is the ims. This is the rows, this is the ims, and according, depending on the numbers or the real numbers, the complex number will range maybe from there to there, Then from this guy, we'll talk about the modulus in the argument. Okay, let's talk about the, the argument in the modulus. Where this is interesting. This is the interesting part. Okay, so the modulus. This is the diagram. The modulus is going to be the length of this line. This is going to be the theta, which is known as the argument, but the modulus is from here to there. Let me even denote it. This is going to be the modulus. This r is the modulus. Then this theta is the argument. Yes, the angle is the argument. Let's talk about it even much better. The modulus is given by what? We saw that the triangle, that's a triangle, it's a right angle triangle. So definitely the modulus is going to be given by what? Since we are saying it's the length, we're going to use Pythagorean theorem. It's going to be given by this x squared plus y squared, and we put the root. That is the modulus, and it's always positive. That's why you're seeing the magnitude. It's always positive. It is always positive. Take note. What about the argument? Argument somehow tricky, but it's very simple. It's also known as the amplitude. Now, it's denoted as, in some cases, they might ask you to find, they just give you this expression, and they're talking about the argument. Okay, so how to find the argument? It actually differs depending on the quadrant you're talking about. You're supposed to move from the positive x-axis and clockwise to the point of interest or reference. Now, when you are finding the argument, it's better first of all you find alpha, the reference angle, which is known as the alpha. Then you go on finding the argument. So this statement is very much important. So we're saying it differs depending on the quadrant you're talking about. If you remember, you used to talk about how many quadrants? They're just 4. 1, 2, 3, 4. There is this one we're saying it's positive. I'm not interested in that. Let's talk about the same quadrants. Okay, so talking about the quadrants, this is going to be the first one. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. Let's talk about it. Now, you're supposed to know where the complex number is going to be. We know that in this first quadrant, x is positive. This side, x is positive, and y is also positive. But this one, x is negative. The rules, they are negative. The aims, they are negative. In the third one, both, they are negative. In the fourth one, the real is positive. The aim is what? Is definitely negative. Okay, so when you have the complex number, it is positive. It is positive. The x is positive and the y is positive. Then it's going to be in the first quadrant. Now, how do you find theta in the first quadrant? Let's talk about it. Suppose this is the complex number. This is our complex number. We're trying to find theta. So in the first quadrant, you should know that theta is equal to alpha. Now, how do you find alpha? Alpha is actually given by tan inverse. This is going to be the this is going to be the x. So you have tan inverse of y divided by what? X, not x divided by y, but y divided by x. Okay, so we are saying in the first quadrant, theta is equal to alpha. So when you find alpha in the first quadrant, it is equal to what? Theta. Keep in mind. What about in the second quadrant? How is it going to be in the second quadrant? How is the complex number going to be? X will be negative, y will be positive. It will be something like this. Now the question is, how do you find the theta, the argument? We're talking about the argument. Okay, what about in the third quadrant? To come and talk about this one. What about in the third quadrant? How is it going to be? We know that both the rows and the im's are going to be negative. In the last one, only the im, the imaginary part, is going to be what? Negative. X is going to be positive. This is what we're talking about. Now let's talk about how to find theta in each of the quadrant. Okay, so we talked about the first one. What about this one? Definitely simple. We said it's supposed to be from the positive x-axis moving anti-clockwise. Boom, this is the point of reference. Now, you don't find theta, this one, direct in this case. First of all, you're supposed to find this angle, which is here, and that is the alpha. So what do you think theta is going to be equal to? It's going to be equal to 180 minus alpha. And don't forget, alpha is equal to tan inverse of y divided by what? X. Okay, let's move on to the second one. What about in the third quadrant? From the positive x-axis, this is not the point of reference. This is not the point of reference. This one. That's our interest. So theta is going to be where? This is theta. You ain't gonna find this theta direct. You are first of all going to look for this guy. That is the alpha. So theta will be equal to 180 plus alpha. We know how to find alpha. Let's move on. Lastly, in the fourth quadrant, this is theta, then this is alpha. So definitely theta will be given by what? 360 minus alpha. Okay, so this is very much important to know. And let's move on to something else. Let's talk about how we can find the same things we're talking about in form of examples. But before we go there, you're supposed to know the special angles. This is very much important. You should know the special angles because you don't use calculators. So if you don't know the special angles, you'll be thinking complex numbers, they're very difficult, but they're really the simplest. Let's talk about the special angles. Okay, so what's going to be sine? What's going to be sine 0? What is sine 45, what is sine 60, that's what we talk about. So what do? You just start counting 0, 1, 2, 3, 4. Make sure you know for sine, then you use it to find cos. It's just going to be the opposite. I'll show you how to do so. So what do? You square root, then you divide by 2. You square root, you divide by 2. The square root of 0 is just 0. Divide by 2, you still get 0. The square root of 1 divided by 2. So you just get half. Square root of 2 divided by 2. Square root of 3 divided by 2. What is square root of 4? It's 2 divided by 2. You get 1. Okay. So on this one, just have 1. Then for cos, just make this one the opposite. So you start 1 root of 3, and this one is going to be the same, root of 2 over 2. This one is going to be half. This guy is going to be 0. What about this one? So this one you get 0. And this one is 1 over root of 3. Then from that, what do? So what I usually used to do is, I'll make sure I draw the box, this box. Then I start answering the questions in the exam. So from this guy, I'll just get the numerator. Again, I get the denominator. Do I have anything to get? No, so it's an error. That's how I used to do it. Okay, so those are the special angles. So when I ask you to say what is tan 60, you should know that it's the root of 3. And let's talk about this guy. We're not going to waste a lot of time on it. Principal argument, just very simple. It's when the argument is between negative 180 to positive 180. How to find it? When the number that you've been given is positive, you subtract by 360. If the number is negative, you add 360. Then you are not changing anything. So on this one, I'm not going to waste a lot of time. Those are just the simple things you're supposed to know. For example, this question. For example, they're saying, what is the principal value of 120? This is already in the range negative 180 to positive 180. So don't do anything to this one. But this one, it's not in the range. It's above 180. So what do? It is positive. We are going to subtract 360. The answer that you're going to get, that is the argument. This one is also positive. So you're going to subtract 360. If it still gives you a number which is not in the range, again you subtract minus 360. Okay, let's move on. Now we can have examples. Find the modulus and argument of each of these complex numbers. Okay, so it's very simple. And what if we multiply or divide the two complex numbers? What will be the modulus and what will be the argument? Okay, so we'll do that as well. First of all, let's find the modulus for this guy. Okay, so we know that the modulus is given by what? Let me use this ink. We know that the modulus is given by x squared plus y squared. Okay, so what are we going to do? Example 1. What is x? It's actually 2. So it will be 2 raised to the power 2. Then y is what? 2 root of 3. This will be raised to the power what? 2. Okay, so this is going to give us 4. And here it will be 4. Root of 3 cancels with the square. So that's going to be 4 plus 12, which is 16. So the final answer is going to give us what? 4. So for the first one, the modulus is what? The modulus is 4. What about the argument? So when finding the argument, make sure you find what is the position of this complex number. Where is it located? In what quadrant? So we can say that they are both what? Positive. And it's definitely going to be in the first quadrant where alpha is equal to what? Theta. So I'll just go direct. Theta will be equal to tan inverse. No need of subtracting by 180, adding by 180. I'll just find this guy. So I'll have, this is y. We said y over x, not x over y. 2 and 2 cancels. So I'll have tan inverse of root of 3. From the special angles, this is equal to what? 60. Okay, so keep in mind, for the first one, the modulus is what? 4. For the second one, that's where we're going. Let's find the modulus of the second example. Let's just do it from here. Okay, so the modulus is going to be root of 1 raised to the power 2. Again, I is also 1. They are negatives, so they're supposed to be in bracket like this. Because definitely this is not equal to this. This is 2. Okay, so what we'll get is they will become positive, and this is going to give us 1. It's going to give us 2, the root of 2. Okay, so the modulus of the second example is actually going to give us what? 2. Root of 2. Okay, what about the argument? Where is it going to be? They are both negative. It's going to be in the third quadrant. And how to find the argument in the third quadrant? I talked about it. It's actually given by what? 180. Are we going to subtract? Yes. Alpha. Then I know that alpha is given by tan inverse 1 over 1. You just substitute the positive ones. So definitely what we're going to get is what is tan inverse of 1? From the special angles, what were we getting? 45. So this is actually equal to what? 225 degrees. Okay, by doing so, we're done. Now the question said, what if we multiply the two complex numbers? So suppose this is Z1, this is Z2. What do you get when you multiply Z1 times Z2? So it's actually very simple. When you multiply, the modulus is going to be 4 times 1 times the root of 2. You multiply the modulus of each individual complex number. So you're going to multiply them. So this is going to give us 4 root over 2. When you are multiplying, you add the arguments. So the argument is going to change to what? The first one is 60, so it will be 60 plus 225. Okay, so this is now it's done. When you divide, it's actually going to be the opposite. Dividing z1, z2. Argument is going to be, the first one that we found for z1 is 4 divided by 1. For z2, this is going to give us 4. Then the argument is going to be, the first one that will go to 60 minus 225. So definitely we're going to get a negative here. Okay, so that's how we do it. Let's move on to something now good. Just like the things we are talking about. There's nothing complex about complex numbers. It's weird. So about the polar form, which is also known as the trigonometric form. The form that we've been talking about so far is known as the rectangular form, which is z is equal to x plus y times the imaginary unit. We talked about this guy, and we know that the theta is going to be there, that is the modulus. Now, the x can also be represented in terms of theta, that is r is equal to cos theta. So this guy is going to be r times sine theta. The complex number, we said it's equal to what? X plus I times y. Okay, so I can substitute this guy where I'm seeing x, and I can substitute this guy where I'm seeing y. So definitely I'll end up getting bam and zibo dude. This is the polar form. So you should know how to find the polar form. When you know how to find the polar form, then everything about complex numbers, my dear, you're not going to be fading. Even when in the next video that I'm going to make, I'll talk about the nth power in the Modulus. It's going to be very simple because you have understood the most important part you're supposed to understand, the complex number. Let's give an example. We'll do this example. Then definitely all the questions, you can do them when it comes to polar form. Okay, so let's talk about this guy. I'll be a little bit slow but fast. We're saying the polar form is represented as the modulus. Then we have cos theta plus I sine theta, not so. So what are we supposed to look for? Just the modulus in the argument. So we are back talking about the same thing. Let's just find the modulus of this guy. So it would be 1 negative. So the negative will always be positive. This will give us 1. The root that side is going to cancel, so it will be 1 plus 3, which is 4. Root of 4 is 2. That is the modulus. We go back to the theta. So I can see that y is positive. Where is it going to be? Y is positive for x is y is negative, x is positive. And definitely it's going to be in the fourth quadrant. So in the fourth quadrant, what did we see? We said that it's equal to 360 minus alpha. So we have tan inverse of what we have, 1. So it will be definitely the root of 3 divided by 1. And I know that the root of tan inverse root of 3 is 60. So I'll end up getting 300. So therefore, the polar form is actually given by 2 cos 300 plus I sine 300. We're done. As simple as that. Let's try this one here. And I'll show you how to find theta even for this one, because a lot of people fails. This is not actually a complex number, but it is a complex number for some reasons. Okay, so the question is saying we find what we express it in a polar form. Okay, so look, my dear, we only have the complex numbers being equal to its real part. Now, when you're finding theta, that's where the complication is. When you're finding theta, we say this equal to what? But this one it can give us what? Now theta, we don't know. How is it going to be? So this one, you don't even usually use this formula. You just look at it. It's only having x, which is negative, which means theta is going to be from the positive x-axis touching this x-axis, negative x-axis, which means this is my straight line. It will be equal to 180. That's all, I'm done. Even looking at this one, I know that it's only having the m's, which is the y in the y-axis, and it's positive, so it will be touching the y-axis at that point, 90. So don't get confused. Even when they give you just a simple number as 2, when they tell you to find the argument, it's very simple. In this case, it's in the positive x-axis, and that's where it's supposed to move from. So there is no angle there. It's just equal to what? 0. Okay. What about the modulus? We are on example 2. The modulus is going to be just 3, because you're going to have 3 raised to the power 2 and 0 raised to the power 2. This is okay, so you end up getting 3. And therefore, the polar form is going to be equal to what? It will be 3 cos, yes, cos what? 180 plus I sine 180. Okay, so Badkoro Babantu Bamonaka Promoter, thank you for watching. In the next video, I'm going to make sure you have understood this first of all. Know how to apply all these concepts we have talked about, the modules, and anything we talk about when it comes to complex numbers. It will be very simple. Zibo, Zibo dude.